Hello class, today we'll be starting our unit 4, which is just on functions, on different types of functions. And today we'll be talking about how to identify functions from either looking at a graph or from an equation. So today we'll be discussing 5 types of functions, and we've seen them all before. None of them are new, but we're just talking about the differentiation between them, or what makes them different. So we talk about linear functions, quadratic functions, cubic functions, and then exponential functions and logarithmic functions. So at some point during this video, I would recommend pausing it and writing all these down in your notes so you have it, so you can compare when we do our worksheet, when I ask you guys to identify what kind of functions they are, just from looking at the graphs, and on some of them I give you the equation as well. So let's start off with linear. So linear functions, they're just straight lines, right? They either go up or they go down, or they can be flat. But the point is that there's no curve in them. And they also, when looking at their function, they have no exponents. So an example would be, let me get a different color here. An example would be something like y equals 2x minus 4. That would be a linear function. Quadratic functions, they create parabolas when we graph them. And those are these U shapes. They either open up or they can open down. But both of them are parabolas. And quadratic function, the highest exponent in a quadratic function is 2. Or you could think, we learned about this last quarter, the highest degree, or the degree of the function is 2. So an example of this would be something like y equals 3x squared plus 1. Something like that. And then we have cubics. Now, cubics we haven't really discussed too much. These would probably be the newest ones to us, but I know for a fact that we've seen them before. Cubics are, I would describe them as a curve with a squiggle in the middle. So notice the whole time it's curving, right? But we kind of change directions here in the middle. We're going up, and then we go flat for a little bit, and then we go back up again. Or we go down, we get flat for a little bit, and then we go down again. So that's what a cubic function will look like. And the highest exponent is 3. So an example of a cubic would be something like y equals 2x cubed minus 6, or something like that. Any polynomial where the highest exponent is 3. Okay. Next we have exponential and logarithmic. So I kind of like talking about these two together, because remember, exponential and logarithmic functions are inverses of one another, so their graphs will look somewhat similar. So with an exponential, you're either going to get something that looks like this or like this, and with logarithmic, you're going to get something like this or like this. Now, you're probably asking yourselves, wow, these are all curves, but how can I tell the difference between them? Well, this is how you can tell the difference, and that's through these first 2 bullet points of each of these. So exponential functions, they increase at an increasing rate, or if they're negative, they decrease at an increasing rate. So what do I mean by that? When we look at the graph, reading from left to right, notice how it's increasing but slowly increasing, and then as we go higher, it increases quicker and quicker and quicker. So we say that this increases at an increasing rate. The rate at which is increasing itself. Or look at this one. It decreases at an increasing rate. So it's going down slowly, but then it starts dropping off faster and faster and faster and faster. So this decreases, or goes down, at an increasing rate. Okay? Now, logarithmic functions, they're both curves as well, but instead of increasing at an increasing rate and decreasing at an increasing rate, when reading from left to right, logarithmic functions increase at a decreasing rate, or they decrease at a decreasing rate. So notice here, reading from left to right, and I always mean reading from left to right, just like we read a book. This one's increasing, and it's going up, but then as it increases more, it's still increasing, but it's not increasing by as much. And so that's what I mean by it increases at a decreasing rate. Likewise, if it were negative, it could also look like this, a logarithmic function. This one's decreasing, but the rate at which it's going down is decreasing as we go from left to right. And so that's the exponential and logarithmic functions when looking at a graph. However, how can we tell what they are when looking at the function or at the equation? Well, exponential functions will have an x in the exponent. So for instance, it would be something like y equals 2 to the x, right? And that shouldn't be new to us. We dealt with that last unit or 2 units ago. I can't remember. Yeah. And then logarithmic functions, it will have a log in it. We should know that as well, right? Like a logarithmic function would be something like y equals log base 2 of x. Something like that. Okay? So these are our 5 functions that we're talking about: linear, quadratic, cubic, exponential, and logarithmic. So again, I would recommend sometime throughout this video pause it so you can write all this stuff down in your notes. And when we do the worksheet, just use this as a guide for all of your to find all of your answers. Because on the worksheet, all we're going to be doing is just identifying it. Well, I guess we can go over an example. Let's say that we are given a graph, and the graphs on your worksheet are much nicer than this because they're copied from Desmos. But say if we're given something like this, the graph, and then the function we're given, let's see, what color do I use? Okay, is like f of x equals x cubed minus 4. Something like that. So I'm going to ask 2 questions. And the first one is going to be, what type of function? And the second one is going to be a justification. How do you know? Well, here I would reference back to my sheet right here, and I'd say, okay, I could either look here or look at the graph, but I'm just going to look at the graph first, and then I'll show you the equation later. Look here, and it looks like this would be a cubic function, right? That's the shape that it gives us. It's a curve with a little squiggle in the middle, right? It kind of gets flat for a little bit in the middle. Sometimes they don't get flat. Sometimes they kind of go up and back down, something like that. But there's a squiggle in the middle. So what type of function is this? Well, this is going to be cubic. And how do you know? Well, I have my choice. I actually know this is cubic for 2 different reasons. One is because of the shape of the graph, and 2, because I said that cubic functions, the highest exponent is 3. In this case, the highest exponent is 3. So how do you know? We could say it's a curve with a squiggle, something like that. I'm sure that's not the official terminology, squiggle, but I like it. Or you can say something like it's a 3rd degree polynomial. Something like that. Remember degree I mentioned earlier in this video? It's just the highest exponent. So when you say something's like a 3rd degree polynomial, you just look at the exponent. Let's go over one more, just for fun, now that we're on this example train here. And let's say now that I'm given a function that looks like this. And let's say this time we're not given an equation, because on some of the questions I'm going to give you, I just give you the graph. okay? So let's say we're not given an equation here. So first we need to identify what type of function this is. And then how do you know? How do we know? So, okay, going through my list here on the left, I know you can't see all of it, but I know this isn't linear because it's not a straight line. This isn't a parabola. It's not quadratic because it's not a parabola. It's not cubic because it doesn't have a squiggle in the middle. And it looks like to me it could be either exponential or logarithmic. But remember what differentiates an exponential function from a logarithmic function when looking at a graph. And that is whether it decreases or whether it increases or decreasing at an increasing or decreasing rate. So here, I'm just kind of looking here, and it looks like this to me looks like a logarithmic function because I have something that is decreasing at a decreasing rate, right? Reading from left to right it's going down, but at how fast is it going down? The longer we go to the right, it doesn't go down as quickly. So we say it's decreasing at a decreasing rate. So what type of function is this? Well, this is logarithmic. And how do you know? Well, I can say something like, well, I can't, because I'm not given the function, I can't say, well, it has a log in it, right? If I were given the function, like log base 3 of 4, I could say, oh, that has log in it, so I immediately know it's a log. In this case, we need to justify by the graph. So I can say something like, this is, how do I know? Because it's decreasing at a decreasing rate, just like that. All right, folks, so that's all I have for y'all today. Again, I would try to remember all the stuff in here, write it down so you have it, and let me know if you have any questions on the worksheet, okay? Have a good day, y'all. Bye.